Today we're looking at isosceles and equilateral triangles. We're going to prove and use theorems about these triangles. A triangle is isosceles if it has at least two congruent sides. When an isosceles triangle has exactly two congruent sides, these sides are the legs. So we have two sides that are congruent, and we're going to label those as legs. The angle formed by the legs is the vertex angle. The third side is the base. So this right here is the base, and then the angles adjacent to the base are the base angles. So we have base angles here. And what happens is if you have two legs, if you go straight across from those two legs, those are the base angles. Now we have the isosceles triangle theorem. If we have two sides of a triangle and those are congruent, then the angles opposite them are congruent. And this works for any isosceles triangle. The opposite is true. The converse of the isosceles triangle theorem says if you have two angles that are the same, the opposite sides are also the same. So let's go ahead and look at example 1. I have SQ is congruent to SR. If those two sides are the same, the angles that are opposite those sides are the same. Angle Q and angle R are congruent. Okay, I've got angle SPQ is congruent to PSQ. And so since those two angles are the same, the opposite sides will also be the same. PQ is going to be congruent to QS by the converse of the isosceles triangle theorem. Okay, so I have this triangle up top. I have two sides that are the same, so the opposite angles are the same. One is 45, so the other has to be 45. If I take two 45s, add them together, I get 90 degrees. So a triangle has 180 degrees. If two of the angles together have 90, the third angle is also going to be 90. I'm looking at that bottom triangle. I have two sides that are the same. So the two angles across from those sides are also going to be equal to each other. So one is y, the other is also going to be y. Now I have three angles in a triangle. One is 50 degrees and the other two match. So I have y plus 50 is 180. I'm going to take that 50 off of 180, and that will be how much is left. So 130 degrees with two angles that are the exact same. So each of those angles is going to have to be 65 degrees to make that 180 degree triangle. So we've got X and Y on that one. Example 4, we have two sides that are the same, or the angles across from that are going to also be the same. So we've got X and X. I also have, notice this X and 110 make a linear pair. If I take X plus 110, that's going to give me 180 degrees. A line is always 180 degrees. So if I take 70 and add that 110 to that, I get 180 degrees. So since one of those base angles is 70, the other is also going to be 70. If you add those two 70s together, you get 140 degrees. 140 degrees plus 40 will give us 180, so that y angle up top is going to be 40 degrees. We're going to prove the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite to them are congruent. We're going to begin with triangle ABC, and AB is going to be congruent to CB. We're going to draw a BX is the bisector of the vertex angle ABC. So we've just taken any triangle where we have two sides that are congruent, and we've just made just a bisector of that vertex angle ABC. So let's look at this triangle and kind of figure out why these triangles are the same. We have two sides that are the same, And remember that word bisect, a bisector means it's cut in half. So angle 1 and angle 2 have to be congruent. And then we have our line right here is the reflexive line, so that's going to be the same on both triangles. So these are going to be congruent by side angle side congruent. We're going to write down any given information that is not in our side angle side congruence. Then we will have our side, our angle, and our side. We write our congruent statement, and then we are going to show that A is congruent to C. So this is going to be our corresponding parts of congruent triangles are also are congruent. So this is a lot like the proofs we learned last time. So I want to use as my first statement the given information that is not part of my side angle side is this prerequisite information that BX bisects angle ABC. Now we have another piece of given information where AB is congruent to CB. That's going to be one of our sides. That information is also given. We have ABX is congruent to CBX, and that is going to be because of that bisector. We've gotten the line that bisects it, so by the definition of bisector, or bisects, angle ABX is congruent to angle CBX. Now our last side is BX and BX. Those are congruent, and that it would be by the reflexive property. Now we're going to use our triangle congruency statement. Triangle ABX is congruent to triangle CBX, and the reason would be side angle side congruence. Now our final line is going to be what we're trying to prove. We're trying to prove that angle A is congruent to angle C, and that would be because the triangles are the same, the corresponding parts of congruent triangles have to be congruent. The corollary of the isosceles triangle theorem says if we have an equilateral triangle, that means all three sides are the same, then we also know that all three angles are the same. And one thing I want to keep in mind is that if all three angles are the same, then we're going to take 180, divide it by 3, and we will get 60 degrees for each angle of an equilateral triangle. And that always works. It also, if we have our equilateral triangle, if we have 3 angles that are the same and all 3 of those would be 60 degrees, then all of the sides of the equilateral triangle will be the same as well. Looking at example 6, I have an equilateral triangle here, so all of the sides will be the same. I'm going to draw 5 in for each of the sides, so x is 5. I also have another triangle. The 2 angles are the same, so the 2 sides are going to be the same. So 5 is going to equal x plus y plus 1, so y is going to equal 4. On example 7, I have an isosceles triangle. The 2 sides are the same, so the 2 angles are going to be the same as well. One is 63 degrees, so the other is going to be 63 degrees. Now I have this triangle ABD. I know that all 3 of the angles together are going to add up to 180 degrees. So if I were to take 63 plus 63 degrees, I get 126 degrees for those 2 angles. If I were to take 126 degrees away from 180 degrees, that will get me my angle up top. That gives me 54 degrees for that green angle ABD. Now looking at the other triangle, I have 3 equal sides. So then I'm going to have 3 equal angles as well. And if I take 180 degrees and divide it by 3 angles, I end up getting 60 degrees for each angle of that triangle. So I'm going to just put in 60 degrees there. I am looking for angle ABC. That is going to be 54 plus the 60 degrees. And when I add 54 degrees plus 60 degrees, I end up getting 114 degrees for angle ABC, and that will be my answer. Our next theorem is the isosceles triangle perpendicular bisector theorem. If I draw an angle bisector, on an isosceles triangle, it's going to be a perpendicular bisector. It's going to cut AC in half, and it's going to make 90-degree angle where the angle bisector meets the base. Let's do an example of this on number 8. I have an angle bisector. I have two sides, two legs that are congruent, and so that makes my two base angles congruent. It's still a base angle even if it's at the top. So we have one angle is 32, the other is going to be equal to 32. My y is going to be 5 because I have a 5 on the top, and it's going to meet at that middle at 90 degrees. It's going to be a perpendicular bisector. If I'm solving for x, I want to take 32 plus 90 and subtract that from 180. That will give me 180 minus 122, so x is going to equal 58 degrees. So that would give me my x and my y for example 8. We're going to prove the isosceles triangle perpendicular bisector theorem. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So we're going to show that the line is perpendicular and that AX is congruent to CX. So if we know these two sides are congruent. Next, we're going to prove the isosceles triangle perpendicular bisector theorem. If a line bisects the vertex angle of an isosceles triangle, then the line is also perpendicular to the bisector of the base. Bisector means that it cuts it right in half, and it also makes a 90-degree angle here. So let's start by just kind of thinking this through. We have two sides that are the same right here. We also know that these two angles are the same because the line is, because it's bisected the vertex angle, and we have a reflexive line here. So these should be the same by side angle side congruence. We don't have any extra pieces of information, so we're going to go right to our side angle side. We're going to write a congruent statement, and then we can use CPCTC to show that AX is congruent to CX. But we also need to show that when we're done, we need to show this last step here. So let's just go to that point. We know that AB is congruent to BC, which is given. Our angle is also given. Our last side, BX, is going to be congruent to BX. That is the reflexive property. Now we're going to write our triangle congruency. Triangle ABX is congruent to triangle CBX. Our reason is side angle side congruence. Now we're going to get this last AX is going to be congruent to CX. The triangles are the same, so the corresponding parts of congruent triangles have to be congruent. We're now going to go to the second part of this proof, and that is to show that BX is perpendicular to AC. Now what I need to do is I'm going to show that these two angles here are equal, and also that they add up to 180. And we're gonna just start with AXB is going to be equivalent, congruent to angle CXB. That is also by corresponding parts of congruent triangles have to be congruent. I know that the measure of angle AXB plus the measure of angle CXB has to be equal to 180 degrees. And the reason is because those are two linear pairs. Now, since those are equal, what I can do is I can substitute AXB in for CXB, and we will have the measure of angle AXB plus another measure of angle AXB equals 180 degrees by substitution. By combining like terms, I get 2 times the measure of angle AXB equals 180. Now my reason for that is by combining like terms, I want to just divide both sides by 2, and so the measure of angle AXB equals 90 degrees, which equals the measure of angle CXB. That is going to be because of the division property. And since both of those equal 90 degrees, BX has to be perpendicular to AC. And so that will be by the definition of perpendicular.